So let's look at one more triangle in section 6.5. So again, solve the triangle. So in this case, I have the angle A is 40 degrees. Side A is 4. Side B is 5. So I'll start with a generic triangle. Let's do A, B, C. Here's 40 degrees, here's 4, and here's 5. So again, I'll have to use my known pair. So I'll use my 40 degrees and my 4, and then let me use my B pair. Let me multiply up the 5. So what I am left with is sine B is 5/4 sine 40 degrees. So this is really equivalent to this step in the previous problems where I had something like maybe sine of A or whatever is 1/2, right? And then we said, okay, well, we know the two angles where sine is 1/2, 30 degrees and 150 degrees. The difference is this time, well, I'm kind of stuck because I don't actually know the value of this quantity. So there are a few problems mixed in here that are calculator appropriate. So this would be an example where I would need a calculator to determine the value of this quantity on the right side. So if I enter, let's get rid of this. If I enter this guy into my calculator, let's see what I arrive at. So then I arrive at sine of B is approximately 0.8. Okay, so I needed a calculator for that step. So let me then think, okay, well, again, on my unit circle, there would be two places where sine would be 0.8, one in quadrant 1 and one in quadrant 2. So actually, to get this first angle, the one here in quadrant 1, I could actually just enter the inverse sine of 0.8. Because remember, the inverse sine is going to give me an angle on the right side of the unit circle because that's the range of inverse sine. So if I enter that into my calculator, that gives me approximately 53 degrees. Now, I still have to account for the other possibility for the angle B. So remember, that's looking at this guy over here. So let's use the highlighter. So if this is 53 degrees, then so is this, right? So couldn't I get that second possibility for B again by taking 180 degrees and subtracting 53? So what is that, 127? So now my two possibilities for B would either be about 53 degrees or about 127 degrees. Now I have to ask the question, do both work? In other words, when I go back up to the triangle here, if I put, say, 53 degrees in here for B, does that form a triangle? Well, yes, because I have 87 degrees here then, right? So that one works. Let me look at the other possibility then. So the other possibility let's see, this was the 53 degrees, right? Is 120, 53 degrees I already accounted for, right? So the other possibility is actually the 127 degrees. So if B is 127 degrees, will I still have a triangle? Well, that would be 167 degrees. That's still less than 180. So actually, both of these work. Yes, both form triangles. And how do I know? Well, because in both cases, both sums are less than 180 degrees when I go back to the original triangle. So what do I do now? So now I know I have two cases. I have a case 1 and a case 2. Because I know I'm dealing with two triangles. So what I would do here is I would actually break this into two separate cases. So let's say case 1 is when the B is 53 degrees. Case 2 is when the B is 127 degrees. Okay, so let me see. So what information do I have? I have the angle A is 40 degrees. B is 53. So I'll try to do a little bit better job of maybe drawing this triangle. So here's, say, a 40-degree angle. And then here's, say, a 53-degree angle. And then what other information was I given? That's A, B, and C. So I was given, this guy was 4, and this guy was 5. Okay, my other triangle, at least to start out with, let's see, the A is still 40 degrees, but this time the B is actually 127 degrees. So I'll it's gonna look like that this time, huh? And then here's my 4, here's my 5. So then I just have to fill in the missing information for each of these cases, same as before. Okay, so I'm just gonna break this up. So let's see. Here my missing angle would be, what was that one, 87? Here my missing angle would be 13 degrees. So all I really have to fill in for each of these is this missing side, C. So I could use the 40 degrees or the 53 degrees. It doesn't really matter. Look like so. Same idea here. And then I'd have sine of 13 degrees over C. So these are going to be really similar as far as solving goes. So one would say C sine 40 degrees is 4 sine 87 degrees. This one would say C sine 40 degrees is 4 sine 13 degrees. So C would be 4 sine 87 degrees over sine 40 degrees. And here would be 4 sine 13 degrees over sine 40 degrees. So there's my last side. So in this case, where I have two triangles, I actually needed to look at both cases separately. What about a word problem? A plane is overhead east of us both. You are due east of me on level ground. At one instant, you measure the angle of elevation to the plane to be 85 degrees. I measure it to be 70 degrees. I know the plane is 330 miles from me.
I'll let Destiny know. I'll let her know when we can go. Okay, thanks.
And then let me answer some questions. So let's start with number one. How far is the plane from you? So I have to start with a diagram. So a plane is overhead east of us both. So I don't know, here's my plane. Let's see, you are due east of me on level ground. So I'm gonna have something like this. So I don't know, here's start, here's me, here's you. Okay, what else can I fill in? So you measure the angle of elevation to be 85 degrees. I measure it to be 70 degrees. I know the plane is 330 miles from me. So the distance from me to the plane, that guy, is 330. Okay, then the first question is, how far is the plane from you? So it looks like what I'm trying to find then is that distance. So let's see what I can fill in. I mean, I know a couple of things. I know this angle here, that's 180 degrees, right? So couldn't I fill in, let's see, this guy would have to be 75 degrees then, right? 75 plus 85 gives me my, oh, wait a second. That's not right. So I need 85 plus my unknown angle to be 180 degrees. So what should this one be? This one should be 95 degrees, shouldn't it? Double check. 95 plus 85 is 180. So that looks good. What else can I fill in? Well, if I add up this guy, and this guy, that sum, so 70 plus 95 plus that missing angle has to be 180 as well. So what is that? That's 165. So it would be 15 degrees. Okay, let's see. I bet you I can find this angle because I know if I add 85 and 90 with this one, I'd have to get 180 again. So let's see what that would be. So 90 plus 85, well, that only leaves me with an additional 5 degrees up here. Okay, let me clean this up a little bit. That was 70? 70?
Right, so that was
70 degrees, right? Okay, so it looks like I have my diagram set up, and then again I'm looking for that length. So let's call that, I don't know, that's D. So let's see what options I have. I think what I'm going to do is I'm going to look at this triangle here, and I'm going to see if I can apply the law of sines. So let me see. I guess I could do something like sine of 95 degrees over 330 is sine of 70 degrees over D. So that would be what? D sine 95 degrees is 330 sine 70 degrees. So D would be 330 sine 70 degrees over sine 95 degrees. And that would be in miles. So I found that missing value D. Let's see what another question is that I could maybe ask you. What about for a part 2, say how far are you from me? Okay, so what am I looking for this time? I'm looking for this distance then. Okay, so again, I'm thinking law of sines, looking still at this triangle. So let's see, what about sine of 15 degrees over, I need to give this guy a name, L. Sine of 15 degrees over L is sine of 95 degrees over 330. So then I'd have L sine 95 degrees is 330 sine 15 degrees. So L would be 330 sine 15 degrees over sine 95 degrees, again in miles. So maybe one more part. So how about for number 3, how high is the plane? So let's see what I'm looking for this time. So I guess in this case, I'm now looking for that height. Looking here for H. Okay, now remember, so what information do I have? I know this distance here, D, right? Because I actually found this distance right over here. So if I go to set this one up, let me see. Well, actually what I'm noticing here is that this is actually a right triangle. So actually, couldn't I just use the definition of sine and say the sine of 85 degrees is, well, the opposite over the hypotenuse, D? Now, of course, I found that D right over here, right? So wouldn't this just look like sine of 85 degrees is H over 330 sine 70 over sine 95? So then if I just multiply this up, H would be 330 sine 70 sine 85 degrees over sine 95 degrees, and that would also be in miles.